So the cosine, sine, and area rules, yeah, is what I'll show you in that. The most important thing to use is that these are not right angle triangles, all right? So using these rules for what we will call non-regular triangles, where the sides and things are all different, angles are all different, all right? Those are the most common types that you're going to come across, all right? And the important thing is to set up triangle, identify what's going on, all right? The most important thing, all right, as you can see here, is labeling it correctly. It doesn't matter which way round you put your A, B's, and C's, all right? But in the cosine, sine rules, the area rules, all right, the main thing is that each side, so for example, this A, is associated with the angle opposite it, all right? So little a there denotes the side, okay? And big A denotes the angle that is its opposite. So do you see how they are related like that? Yeah. So always keep those in sort of corresponding pairs. So angle B here is related to the opposite side, little b, all right? And I know the C's look the same, but this little c here is the side, and then a capital C would be the angle. Does that make sense? Yeah? So as long as you realize what's related to what, then the cosine sine rules are not actually difficult. Okay? The rule comes out like this, all right? So imagine I wanted to find what A is, all right? So I want to find the length of that side. So the standard form that you get in your GCSE paper is that A squared equals the side B squared plus the side C squared, all right, minus 2BC cos the angle opposite the side that we want to find. That, right? So this is the order in which to put it. So effectively, if I want to find a particular side, A, it doesn't matter which side, I take the squares of the other two sides, add them, and then do the minus 2BC or whatever it is that I want. But the angle here has to relate to the side that I want to find. That is the crux of the cosine rule. All right, does that make sense? Yeah, all right. So you can easily rearrange that. So for example, if I wanted to find the side B, yeah, that one there, okay, I'll just, following that same rule, I want to find B, so I take the other two sides, A and C, I take their squares, so A squared plus C squared, minus 2AC, and here I want cos of angle B. Do you see how they're connected like that again? All right? Same principle. So you can use it for whichever side you want, as long as you use the right components to the formula. All right. Okay, so that's the basic thing. And maybe I'll just do one little example. Same sort of triangle again. In GCSE, you're more likely to find just plain scalene triangles, so the ones that are like all different sides and whatever. Okay, something like that. So imagine I have a side there, 5, and I've got a side there, 8, and I've got an angle of 40. All right. The way that the the cosine rule is used, all right, is that you need a side angle side. All right. And I'll explain what that means. So side angle side, right? So use the cosine rule when effectively you've got, two sides, let's say, All right? That's terrible, but doesn't matter. So you know this one, you know that one, and you know the angle between them. Okay. If I were to be given an angle outside of those two, so one of the other two angles, you can't use the cosine rule. It's got to be the side angle side arrangement. Okay. Does that make sense? Yeah. All right. So in this particular one, let's say I wanted to find that side there. Right? The third side is what I want to find. So let's actually just work through it. So I want the questionable one. Let's call that A. All right. So A squared, using my formula, is going to be the square of each of the other two sides. 5 squared plus 8 squared minus 2 times 5 times 8. Yeah. And then cos of the angle between them, which is effectively the one related to the side A that I'm after. All right. Cos 40. All right. So simplify that a little. So 25 plus 64 minus 80 cos 40. And let me just put that in the calculator. 9 minus 80 cos 40. And we get 27.7164 dot 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 and so on. All right. So therefore, from there, A, if you square root it, all right, just putting in the square root of that is 5.26 to three significant figures. Does that make sense, the procedure for that?
Yeah.
Yeah? All right. Remember, as I said, the important rule is that it's got to be this side angle side arrangement to use the cos rule to find another side. Okay. Now, using the same sort of triangle, all right, we can use the cos rule. If we know, for example, three sides, we can actually use the reverse cos rule to find an angle. All right. So I'm picking sort of just random lengths. I have no idea how this is going to work out. Let's see. Okay. So again, imagine I've got 5, 7, and let's make this one 9, I suppose. Let's do that. All right. So we have three sides now. Okay. And imagine I want to find this angle here. That one there. All right. So the way to set it up, remember the 5 is the one related to the x. All right. So we're going to set up our original formula as we know. So 5 squared is going to be 7 squared plus 9 squared minus 2 times 7 times 9 cos x. That would be the formula that we're given, right? So we just put that in there. All right. The way to do this now is to rearrange it to get cos x on its own. All right. So, all right, if I do it in full, so you see it once, thereafter you can just use the reverse formula. But I'll show you how it's done. So we've got 5 squared plus 2 times 7 times 9 cos x equals 7 squared plus 9 squared, right? And moving the 5 squared to the other side now. Like that. You follow so far? Yeah. And then, because we want cos x on its own, we divide the right-hand side by the 2 times 7 times 9. All right? Okay. I've deliberately left all the numbers with squares and things on them because I wanted to show where it all comes from. All right? So I haven't actually calculated anything yet. So if I now actually do the calculation, right, simplify the whole thing, 49 plus 81 minus 25 over 18 times 7, 126. All right, that's your cos x. And so that, you know what, I'm just going to put a number in there. Because that 105 divided by 126 actually comes out to be 5/6. Not bad for a random triangle, all right? And then the final step is just to do inverse cos of 5/6. Does that make sense? Yeah? See where we've come to on that. So inverse cos of that, and we get x equals 33.557 ... So you would write that as your GCSE answer, as it were, 3 significant figures, 33.6. All right? Now, so what we've achieved here, all right, if I go back to the original thing, so from here, we can just say what the formula is, all right? So cos, let's say we want to call it angle A. Cos A equals the other two sides, all right? So B squared plus C squared minus the side, remember the 5 squared, that's the one that corresponds to the angle A, oh sorry, angle X in this case, right? So A squared divided by 2BC. That is the inverse cos rule. And then obviously once you work out all the numbers, you just do the inverse cos of it, right? So angle A, degrees, would equal all of that. Just inverse cos it at the end. Any questions so far? No? Do you see how to use that? All right. So as long as you have the original formula, either you memorize it or you have it in your actual exam formula sheet, depending on which board you're doing, you can easily rearrange that, the way that I've done here, and get to the inverse cos rule. All right? Okay. Any problems? Anything you want me to explain further? No?
No, I understand.
All right, cool. Then we have the sine rule, okay? And let's put that in here. Okay. What happens with the sine rule is that if we have a triangle where we don't have, the requirement for the cos rule is that we know a side, an angle, and the other side. So 2 sides and an angle between them. Let's say we don't have that, all right? Instead, we have 2 sides, and again, I'm going to use these standard numbers that I'm using, and I've got a different angle. You know what? I don't even know what angle I should put here, but all right, let me see if 40 works. I'm not sure. I want to give that a random try, all right? So I've got, as you can see, a side, another side, but not the angle between them, but one of the other angles, all right? So the angle that we do know is not included by those 2 sides, all right? Does that make sense? Okay. In this case, what we can do is we know that the 5 is related to that angle there, the 40, all right? And therefore, the 9 is going to be related to that angle there, all right? Do you see how those correspond right from the beginning of the notes I was making, right? So we can actually use a rule given to us, and it doesn't matter which way up, I'll show you. There's a rule that says each side, right, the ratio of each side to the sine of the opposite angle. So side A, ratio or fraction if you like, sine angle A is going to be the same as a ratio of side B to the sine of angle B, all right? And side C over the sine of angle C, all right? Those ratios will be constant all the way around the triangle. Okay, it's always an angle, right? Sine of an angle and the side opposite that angle. That's the important thing to remember. Okay, and it doesn't matter which way up you write it. Okay, so you could do sine A over side A equals sine B over side B, etc. All right? As long as you know any two sides and one angle, all right, relating to it, then you can use it to find one of the other angles. The beauty of this is, in this particular example, if I find x, then I know what x is, I know what 40 is, and then I can easily find what the third angle is. So by default, I know the third angle. Okay? Does that make sense?
Yeah.
All right. So let's actually give this one a try. I'm going to try and find x here. So if I write it like this, that, oh, hang on. Let me just undo that. Sine x, I'm going to use it this way up, over 9 must equal sine 40 over 5. Yeah? So rearrange that a little. Like that, all right? So can you see it for the reflection? Is that right?
Yeah,
Yeah?
that's right.
All right. And so let's work out what this is first. So 9 divided by 5 times sine 40. Whoops, what have I done? Oh, I've picked a bad one. What's wrong with this? Tell me what's wrong with this. I've got sine x equals 1.157. What's wrong with that?
Sorry, what?
I've found that sine x, okay, equals 1.157. What's wrong with that?
Angle X looks too big to
Yes,
be.
yeah, that cannot be right because the maximum value of sine is 1. All right. So my random choice of numbers has given us a funny answer. All right. So if I instead change the 9, let's change it to, I don't know, let's make it 7. Okay. So we're going to do it with 7 instead. And let's do that again. That's one of the problems of recording this thing in a lesson. Over 5 times 7. Okay. Let's see if that does any better or not. Yeah, that's a little better. So 0.899 9, 9, blah, blah. All right? And so x, with my little rejigged triangle now, is going to be inverse sine of this 0.89, which is effectively 0.9. Okay? So inverse sine of that, x equals 64.1 degrees, again to three significant figures. All right? With the exception of the little hiccup with the 9, do you see how that's used now? Yeah. So if that's 64, and we know that the original angle was 40, so therefore we know that the remainder is going to be 180 minus those two. Okay? So I can then work out that angle, I'll know it now, and then I have the two sides, and I can either use the sine rule again, or I can use the cos rule to find the missing side. All right?
Yeah.
So, as I said, the sine rule is with a side, and the angle here, right? So side, side, and an angle. The cosine rule is going to be a side, angle, side. So the angle has to be between the two sides that you're given. Okay. So you can use either of them to either find an angle or indeed find opposing side. All right. So depending on what information you're given to begin with, that's where you decide whether you use the sine rule first or the cos rule first. All right. Does that make sense so far? Any questions? No? All right, cool. Last bit is the one that you've already done at school, I believe. All right. And that one is the area rule for an irregular triangle. Okay. I better not choose weird numbers again. Okay. I'll stick to my tried and tested, the original one. What did I do with the first one? It was 5, 7, and 9. Yeah. Okay. So if I do 5 and 9 and I do my original 40, again, the area rule, right, needs two sides and an angle between them, right, to find the area. And for an irregular triangle like this, its area equals half times B times C times sine A. All right. So for short, half B C sine A. And in the formula books, I think you mostly get it written like this. Half AB sine C. All right, so that's the one that you're familiar with. Okay. What I'm trying to demonstrate here is it doesn't matter which way you write it, as long as you have two sides like that and the angle between them. That's the rule that you need to follow. It doesn't matter what you label it as. All right. So in this case, the area of this triangle is going to be half times 5 times 9 times sine 40. All right. So 14.4627, blah, blah. So 14.5, all right? And whatever unit, centimeters squared or something like that. Okay. Now, effectively, you don't need to know how it's derived. Okay. But what this formula is doing, saying that, well, listen, to do a triangle, you want half times the base times the vertical height, right? So this sine A bit effectively is trying to help us find that vertical height, whichever way you look at it.
Yeah.
All right. As I said, there is a proof for it, and even the cos rule, there's a proof for it. These are all, the cos rule certainly, is a variation, all right, development of the Pythagoras theorem. All right. So you can see it starts off looking like the Pythagoras theorem, but then you've got a little adjustment, okay, because you don't have a right angle triangle. All right. So that's the cos rule, the sine rule, and you've got the area rule, again using the sine of an angle, all right, that we've just shown you. Does that all make sense so far?
Yeah, that makes sense.
All right. They might ask you to find an area, but first you have to find an angle or a side. If you have three sides, for example, you need to use that information to find one of the angles, then use the area rule, right, with the appropriate sides to get the actual area. So your GCSE question on this sort of thing might have two parts to it, right? Okay. Right. Any questions? No?
No.
All right. Let's pause there then.